Now, we all know, $1 million question. Simple. You cannot escape a black hole. But shall we try and find out, is there any way to escape black hole? So, what is escaping from black hole? Black hole, in the end, it is just mass, just the way Earth is. How do you escape from Earth? You have escape velocity. How do you put a satellite in the space? You make that satellite or the rocket fly at a speed beyond more than the escape velocity. In case of Earth, it is 11 kilometers per second. So you increase the mass of the planet that you're trying to escape from, like Jupiter, it would be 60 kilometers per second. In case of a sun, it will be 615 kilometers per second. In the sense, the escape velocity is increasing. So obviously, when we are talking about black hole, which is millions and billions of solar masses, the escape velocity will be infinite kilometer per second. So generally, it is said that it is almost impossible for you to escape the black hole in a way way we escape from Earth. But as for the sake of hypothetical discussion, let us assume I give you infinite energy. Go ahead and escape from the black hole. We are saying you need infinite energy to escape from black hole. I give you infinite energy. Go out. Is it possible? It is not. What is more important is infinite energy is only the magnitude, and what is important in escaping from black hole is direction also. In case of Earth or Sun or Jupiter, the direction is very clear. It is radially outwards. You try doing that in a black hole, you cannot, because you don't have a time machine. For you to move out of the black hole radially, you need to have time machine. Even if you have infinite energy, it is not going to help you. So it will have to be concentric. We know that the mass, if you're falling into the black hole, you're taking that concentric circle of the vertex structure. When you want to escape, now it has to be through that concentric circle. So when you are in the concentric circle, there are only two ways to escape. One is either move forward or backward. Moving forward doesn't make sense. If you're moving forward, you're going more towards nearer the core and you would not be able to escape. So the only option left is backward. For you to move backward, you have to, apply the brake, come to a halt, and then change your direction, and then possibly try to come out of the black hole. You have the infinite energy. But we will see that possibly even that is also not possible. To understand that, we need to study a bit about how the speed of the mass and the time around the time zone around the black hole works. Now, we know that speed is distance traveled divided by time. Let us assume that you are away from the black hole, you are moving in concentric circles. The speed there is s by t. The speed, the distance traveled is the circumference of the diameter at this particular time. And let us say t is t, time taken. When you try moving radially towards the vicinity of the black hole, what happens to these three parameters? We know for sure that the distance traveled will be lesser and lesser relative, because the diameter is reducing, the circumference will also reduce. And what happens to the velocity? Velocity should increase, because the more closer you are to the core of the black hole, the attraction force is more, so the speed is far more and more. Now, what happens to the time? The denominator. Generally, what you see here, we say that as you near the black hole, time slows and it comes to a grinding halt when it is at the core. When you say when it slows down, or when it comes to a grinding halt, is t is equal to 0? T is not is equal to 0. T is in fact is equal to infinity. In the sense, the time is slowing down, in the sense time is also increasing as you move towards the black hole. Time is also increasing. But look at this equation. If the velocity is if the distance traveled is decreasing and the time is increasing, which means that the numerator is decreasing and the denominator is increasing, the result, which is speed, has to decrease. But we know the logic says that closer you get, the velocity increases. So how do we explain this conundrum? Important is to understand what is plane of reference, in the sense when you are looking from an external area towards inside the black hole, the time seems to be slowing down, because the plane of reference here, the time, which is t is equal to 1 second, this would look like time which is 1,000 seconds, which is nearer to the black hole. And that is why you may feel that a person in that particular um, time zone is aging less, aging slowly. But what is most important is, if you go to a particular time zone, the time zone of this twin baby, which is nearer the black hole, life would be going on normally for it. For it, the 1 second is 1 second. That 1 second is 1,000 seconds for the grown old man who is far away from the core. When he looks from there, for him it is 1,000 seconds. But for the baby, it is still 1 second. Life is going on normally, which means the time, when you relatively look from outside to inside, the time is slowing down. But when you are in a particular time zone, time is behaving normally, in the sense t is constant. So let us take out t, time, out of the equation and see, when you are trying to move inwards, radially inwards, we want the relative speed to be increasing. I am saying relative speed. It should be increasing. For that to happen, the relative distance the distance traveled also has to increase. But this is a contradiction. When you're moving inwards, the relative distance is in fact decreasing. The only way the velocity can increase when the distance traveled is decreasing is when when the space is slipping. Very similar to a treadmill. So you are increasing your speed, but for others, you are seen as though you are standing in motion. And when you increase the speed of yours, you will have to increase the speed of the treadmill also, so that you are in motion. So in a sense, a mass travels 100 meters, the space sets it off by 100 meters. So when that 100 to 100 is 1:1, that is when you feel the time is stopping. But otherwise, time is moving. So that means the space around the black hole is slipping. It's acting like a treadmill. So what will happen to our escape plan if the space around the black hole is slipping? So let us assume you have that infinite energy that I had given you. You applied the brakes. You came to a grinding halt. Now you want to use that infinite energy and try going backward. Again, when you're going backward, the time slips, the space slips again. So whether you are moving in the concentric circle forward or backward, the space always slips and you will never be able to come out of the black hole, even using your infinite energy. So how to come out? Infinite energy is out of question. The only way that you can come out without any energy is if you have a time machine. You have a time machine, change the time, you will move to the next concentric circle away from the black hole. So you keep changing the time, you automatically move outwards and your speed is slowing down, because when you move towards the core, the speed is increasing. When you're moving away from the core, the speed is decreasing. You keep doing that to such an extent that you come to T0, which is a normal time zone where black hole doesn't have any effect. So the only way to escape black hole is if you have a time machine.